Okay, so naming alkenes is very similar to naming alkanes. So any little tiny ball that you were dropping or not juggling as well as you can on your own from your quiz, learn from that. And you guys are all on a very solid foundation for your alkenes. All of you are. So it's a good place to be right now. So alkane general formula was CnH2n plus 2, right? Alkenes have a double bond in them. I don't want that. I think they just want that. Alkenes have a double bond in them, a carbon-carbon double bond. And so, let me get the board to work for me today. And so they have the general formula CnH2n because 2 hydrogens were taken off to make the double bond. So instead of 2n plus 2, it's now just 2n. Okay? And so by definition, they have a carbon-carbon double bond. And because they have a carbon-carbon double bond, they're considered to be unsaturated. What did saturated mean? All carbon-carbon single bonds. And so now we don't have all carbon-carbon single bonds, rather we have a double bond. So who's heard of unsaturated fats? Oh, ta-da! Versus saturated fats. Get it? All it means is one has a double bond in it, or more than one actually, and the other one doesn't. Okay? All right, so there you go, there you go. So nomenclature. Any questions on that so far? So do you see how this follows C2H4, therefore it's CnH2n. So C100H200 would be a carbon chain of 100 carbons where you had a double bond in between 2 carbons. Okay? Questions? Fabulous. So how to name them? So when you're naming them, you're going to end in -ene. I pointed out quite often that when we were writing our alkanes, everything ended in -ane, ethane, propane, and yesterday when we were doing the dramatizations, you were able to, I said, what would that be named? And you said propene, right? Great, so you've got the point that alkenes end in the ending -ene. Okay, to indicate the presence of the double bond, you still go with the longest continuous chain of carbon atoms, but remember how we came up with one example with the alkanes and I said, oh, you can't have a branch off a branch, so have another look. Your longest continuous chain must have the double bond in it. Okay, so even if you find a longer one, but it means you have to skip the double bond in the longest chain, it's not that one. So the longest continuous chain has to have the double bond in it. And then that determines the end name bit, propene, pentene, butene, etc. Okay, just like I did before. And then we're going to name our branches the same: methyl, ethyl, propyl, chloro, bromo, iodo, all the same sort of branch names. But when we number the carbon chain, we have to number the lowest possible number so that the branches and the double bond has the lower number. So we're going to actually number the double bond as well. And so when we're doing our numbers, do we number it left to right or right to left? We not only take the branches into consideration, but also where the double bond is. Okay, I'll give you an example. I've given you an example. Okay, so yesterday I think somebody made propene in their dramatization. So here's propene. Can everybody see it's got 3 carbons? As one would expect with prop, and it has a double bond in, so we've named it -ene. Everybody get that? Okay, this one, longest continuous chain, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 6 all the way around. So for simplicity, we'll go this one. Now, this is a hard example to start with. That's okay, we'll just jump right in. Where your double bond is, will make a different molecule. If you were building this molecule versus building this molecule, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and still having off of carbon 3 the ethyl, and still having the ethyl come down there. Do you see how that's different with the double bond at the beginning? So we've got to name that double bond. Excuse me, I've got something in my throat. Okay, so can you see where they get the name 3,4-diethyl 3-hexene from?
Yes.
Oh, except for this is old school. That's old school. That's old school. It should be named 3,4-diethyl. Everybody okay with that?
Yeah.
The hex is on carbon.
Oh, good.
Hold on. Where did I put the extra sheets? Did anybody see? I had to staple a sheet of that one. I had to staple a sheet on the top.
Okay. All right, thank you.
So 3,4-diethyl. Everybody okay with that? Hex, because it's 6 carbons long. 3-ene, because the 3 is where the double bond is. So the 3 goes in the middle, whereas it used to go on the end.
Why did they change that?
Yeah.
That kind of makes it more complicated.
No, they changed it because it's actually more correct. You know, if the 4 is where the ethyl is, the 3 is where the ene is, makes more sense. And what if I had an ene and later on you're going to learn a triple bond and say Y and E? What if you had a double and a triple? Now I can say the 3 is where the double bond is and the 5 is where the triple bond is. Let me just put up a screen. How do I do that? Of let me just put up a screen. Oh, not that one. This one. Cool. Okay. All right, I think I've maybe lost you because it's Friday and because I'm being a bit scatty. You ready? Here we go. Naming double bonds. If this was an alkane and you went 1, 2, 3, 4, 5, what would you call it? Pentane. Everybody okay with that? Okay. Now I'm going to make it an alkene. How do I make it an alkene? On a double bond. Where would you like your double bond? Jillian. Jillian gets to pick. Sure. 1, 2, 3, 4, 5, 6. No, 6? 5. 5. Got you a little carried away. Super excited about chemistry today. 1, 2, 3, 4, 5. What are we going to call this? Pentene. Okay. Pentene. Like, no, not like that. All right. Who disagrees with Jillian and says, I don't want the double bond on the first carbon? Anybody out there disagree with Jillian just for fun? Thank you, Craig. Always up for disagreement. Craig, where would you like the double bond?
3.
Number 3. 1, 2, 3, 4, 5. So 1, 2, 3 there. Yeah? Okay. Devin, what's this called? Oh, pentene 2, but you know what? They're different.
3.
Devin, where do you want your double bond?
The last one.
The last one. 1, 2, 3, 4, 5 there. Which molecule is Devin's? I'm going to number them. Molecule A, B, C, D. Which molecule is Devin's similar to? Or the same as?
B.
The same.
B.
B.
Because it's
Right, let me take it off the board for you. Let me turn it around and give it to you. Oh, now the double bond is, right, double bond's where my pen is, on Devin's. Turn it around, now the double bond is where Jillian put it. Okay, so D and B are the same molecule. Did you get that? We need to name them different if they are different. So this one's going to be pent 1-ene. Because I put the carbon, the double bond on carbon 1. 1, 2, 3, 4, 5. And this one is still carbon 1, 2, 3, 4, 5. Abby and Andy, please be quiet. And so this one's still called pent 1-ene, and so it's the same molecule. The middle one, what are we going to call C? Pent 2-ene. Good, because 1, 2, 3, 4, 5. So this is called pent dash 2 dash ene because the ene bit is on carbon 2. Yes?
So, B and C are isomers?
B and C are isomers,
And
correct?
C and D.
And C and D are isomers, and B and C are the same.
Yeah.
And they are not isomers of that alkane.
Yeah, the alkane is just.
Right.
So isomers apply to like alkanes, alkenes,
Right.
all
So
those.
like
Yeah.
pentene and
But they all have to have the same double bond.
They have to have,
Yeah.
they have to
Have
have
to have a
one
double
double
bond.
wouldn't all those be isomers?
Pentene and pentene and.
You can't cross out.
You can't cross them.
So pent, same molecular formula, different structural formula. Pentane, in its molecular formula, has 2 extra hydrogens,
Right.
right?
But
So
all
therefore,
those things on the board just now at the same time are isomers.
well, this column are isomers,
Okay.
but not that column. And because those are the same, you actually have 2 isomers on the board. 2. I've got, this is an isomer. Oh, that didn't work. This is, okay, it works red. This is an isomer of this.
So it's the last one.
Okay, but the last one is the same as that, so you'd only get 2 marks, not 3.
Why is it an isomer?
Pardon?
I'm confused.
Why isn't this an
Or
isomer?
why are they?
Because they'll have the same molecular compound formula, but different structural formula. Same molecular formula.
Or like as pentane?
No, of each other. They are isomers of each other.
C5H10.
These are C5H10. This is C5H12. It has no relation to this. Okay, pentane has no relationship to pent-1-ene other than the word pent. So one Samantha is not related to the other Samantha. However, the Smiths are related. They're cousins. It's true. All right, let's very, very quickly move on. All right.
I've kind of an unrelated but related question. Remember when you were saying that you can't have methyls on your first? Like you can't have methyl on your first carbon because it'll extend the chain. You can't have your ethyl on the second carbon? Okay. Correct. I forgot which.
And then draw this.
No.
It's not on our sheet.
No, find a spot in the corner.
Pent 2-ene.
Find a spot in the corner.
Just right on that.
Yep, fine. Don't care. Let's do it. Hurry.
If it's on,
Yeah.
is it like
So 2 is it on Jillian first?
Sorry, does that mean it's between 2 and 3 or between 2 and 1? Or
It means it's between 2 and 3.
okay.
So it has to go after the number that comes with it.
Yes. Because you would always give it its lowest number, right? So if it was the other way, you would have given it the 1.
Yeah.
Did you start with that?
I'm on there.
And then the methyl goes on carbon 2. Have you put in your hydrogens?
Yeah.
This is where you will make a mistake, if you haven't already.
There's already on the one beside.
That's right, Devin. There's already 4. So this is CH3. This is C nothing. This is CH3. This is CH.
Why does that seem nothing?
How many sticks are on that carbon? How many sticks are on that carbon, Raj? You don't know how many sticks? 1, 2, 3, 4. Okay? 4 sticks on carbon.
Yeah.
Got it? Shh. Girls at the back. Mostly Andy. Need to focus. Focus. And so this one only has 1 hydrogen. Did you get that? No. And this one has 2, and this one has So students will make mistakes on their hydrogens here because there and there. If you are the type of person that is prone to making mistakes on your hydrogens, do not write these CH2, CH3s. Start writing the sticks. Because 1, 2, 3, 4, 5, the double bond here and the methyl there. If you had written sticks like this, 1, 2, 3 hydrogens, you would have caught yourself here. You would have said, oh, I've already got 4 sticks. Now 4 sticks. 1, 2, 3, 4 sticks. 1, 2, 3, 4 sticks. 1, 2, 3, 4 sticks. Okay? So the fallback plan that I tell students is always draw all those sticks out. That's called a displayed formula, right? So always draw the displayed formula if you think you're going to get tripped up by not putting hydrogens here. And students that get tripped up putting no hydrogens there, just do it too fast. So if that's your personality, to just whip through the end bit, you'll want to put sticks. Then you don't make a mistake. Okay? All right, so back to the sheet then. I think I'm on that one. So draw the same of bond isomers are either aliphatic alkanes or cyclical alkenes. Okay, so let's go back to this board and let's draw some isomers of that one. So, can we find some isomers of 2-methylpent-2-ene?
What are alphatic again?
Straight chain.
Cyclical circle.
Yep. So can we do the isomers of 2-methylpent-2-ene? I'll give you a second to do 3. Okay. No. Probably not finished. I know you're probably not finished, but how about this for one of the isomers? Just the straight chain, 5 carbons.
Wait. What?
Alright.
Oh, because it has the same, okay, yeah.
How about this for an isomer?
Doesn't it have 6?
Does it have the,
That one spells.
what is the molecular formula of this? C6H12. What's the molecular formula for this? C6H12. So do they have the same molecular formula? Different structure? Okay, what would we call that? Pardon?
Well, that one's
Hex 2E.
Hex 1E.
So would hexene never exist then? Like hexene alone?
Hexene alone is not an oh no, correct. Sorry, I was.
It would never exist because it would have to have
Correct.
something to double bond.
That's right. So there's no such thing as hexene. You have to say hex 1-ene or perhaps hex 2-ene.
So that goes with all of them, right? Like you
6.
can't just have propene anymore.
No,
Or
it does exist with propene and ethene. Why?
Oh, so you can't
because
be
you can
anywhere.
only be on,
Can't wear any. Well, I'll show you after we finish this. Okay.
you can only be on one.
So this is hex 2-ene. Everybody all right? An isomer of this would then be hex 3-ene. 5, 6 with double on there. Hex 4-ene. Don't allow?
No.
No, because
It's the same as 2.
same as 2. I would start numbering it from right to left. So those are all the straight chains. There's one with the methyl branch. Here's hopefully one that you came up with. 1, 2, 3, 4, 5 methyl, but the double bond's here now.
What is that one called?
What would that one be called? 1, 2, 3. So it's pent 3-ene.
You
That
can't
says
have
pent.
pent 3-ene.
You can if it's not a straight chain.
But if you go the other way.
And this is 2-methyl. Okay, so let me just name this slowly then.
I'm sorry, please.
No, you're not confused. You're all right. Okay. Everybody see that that's an isomer?
Yeah, which one?
This one. Everybody okay? All I did is take this compound and I moved the double bond over here. Did you not come up with that one on your own? I thought
Wouldn't
maybe
that be
like
the
a
same
word-
name the other way? Isn't it 2?
Okay, so now let's name it. 1, 2, there's a 2, so here's an option. 2-methyl, 3, so is this going to let me write on this? No. This one was 2-methyl pent 2-ene. propene. Okay, so this is called, if we number it this way, 1, 2, so 2-methyl pent 3-ene, or if we numbered it right to left, it'd be numbered 1, 2, 3, 4. So now we've got 4-methyl pent 2-ene. This adds up to 6, that adds up to 5. So this is the lower numbering system, so that gets its name. I'll say that again slower. If I numbered it this way, 1, 2, 3, 4, it'd be 4-methyl pent 2-ene. But 4 plus 2 equals 6, and 2 plus 3 equals 5. So therefore, this one wins, and I would be numbering it left to right, not right to left. In either case, both names are different than this name, but still the same structural, molecular formula, C6H12. So therefore, isomers. So this name is wrong. That name is right, and they are isomers. All of these on the board are isomers so far, because they all are C6H12, and they all have different names, and they all have different structural formulas. Are we all right? So who came up with that one? I thought that'd be the first place you went. Yeah, move the double bond. Okay, so who moved the methyl then? Okay, let's do that one then. So let's go back to this. 1, 2, 3, 4, 5. You kept the double bond in the middle, and you moved the methyl like here.
Yeah.
Yes? Can I move the methyl onto the end?
No.
No. So this is called 3. Yes? 3-methyl pent 2-ene. Have you ever heard of that? You can have a 4-methyl pent 2-ene as well. Oh, 1, 2, 3, 4, 5. Double bond is going to go here, and this will go here. 4-methyl pent 2-ene. I could have lots of pent 1-enes with the methyl in carbon 2, 3, or 4. So I could have 2-methyl pent 1-ene, 3-methyl pent 1-ene, 4-methyl pent 1-ene. See how they're like lots of isomers, right? So for a question like this, I wouldn't say draw every possible isomer. I might as a classroom exercise just to get your brain going. But in a test, I would say draw 3 possible isomers, or 3 branched isomers, or 3, okay? So then I'm only looking for you to come up with 3 different ones and not the same. Devin first and then Evan?
Isn't that the same?
Which one?
Like if you just flip it, the one that you just put a check mark beside?
This is 1, 2, pent 2-ene, 3-methyl. Yes, it is. Yeah.
I just meant to put the 4.
I think I meant to put 4.
Oh, okay.
1, 2, 3, 4, 5. Do I need to move the? I can't remember what I was talking about.
I think you should actually put the branch over 3 instead of 4.
Okay, whatever. Evan?
Wait, so it's different if you say have, so you can have a 4-methyl pent 1-ene, because the double bond's there, it's the.
Can I have a 4-methyl pent 1-ene? Is that what you're
Yeah.
asking? 1, 2, 3, 4, 5. Pent 1-ene. 1, 2, 3, 4. Methyl, definitely.
So you can, it doesn't flip, because then that changes where the pentene is, okay, yeah. I'm confirming with myself.
Okay, now, so do you see how you, and I could come up with probably quite a few more, because we haven't even embarked on our butenes or propenes, right? And we end up with dimethyls and ethyls. So you can see how there would be a substantial amount of isomers. This is a big old family. Okay, so these are all aliphatic isomers. APH? Aliphatic isomers. Aliphatic.
Aliphatic.
aliphatic isomers? Aliphatic just means a straight chain, but it can be with branches, right? So I mean a straight chain or a branch chain. Okay? But what if, and somewhere along this conversation, we saw the word cyclical isomers? Okay? So I'd just like to just kind of have a little bit of space here. I'll just clear this off. And can we come up with a cyclical isomer? So a cyclical compound goes in a circle. And so how many carbons do I need in this circle? 6 carbons. Okay? So I need 6 carbons to go in this circle because I have C6H12. Right, everybody? So we're going to go 1, 2, 3, 4, 5, 6. Okay? And how many hydrogens on these carbons? If Raj, I only get to have 4 sticks. So 1 stick, 2 sticks, how many more sticks on that carbon? How many sticks does carbon have, Raj? 4. So I've got 2. How many more do I need? 2. So 2 hydrogens. What about that one? Same. 2 hydrogens. Can you see how these are all going to be 2? And can you see how my C6H12 will be formed? No double bond.
Doesn't that mean it's not?
On the bottom of this sheet, it says isomers of alkenes are either aliphatic, straight chain or with branches, alkenes with a double bond, or cyclic, circle, alkanes. See that? Because I've drawn it in a circle, one of the bonds is like the end bits are taken up. So I had to take off 2 hydrogens in order to bring that into a circle. Okay?
So they're all CH3s?
They're all CH2s.
Oh, right.
They're all CH2s. Everybody give me the drawing. How would you name this? First of all, how many carbons? 6. So how do we say 6? Hex. Is it an alkane or an alkene? Ane. So it's hexane. Only is it hexane? No. So they put a little cyclo in front of it to mean a circle hexane. So this is cyclohexane. Instead of just hexane, which would be a nice line. Okay. And cyclohexane is an isomer of 2-methylpent-2-ene because they both are C6H12 and they are very clearly different structures. You see that? What about this one? 1, 2, 3, 4, 5. H2, 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 CH3, H2. What? Oh my gosh, what did she just do? So I built a little house, right? Looks like a house. You put a carbon on every corner, and that makes it C5. That's a nice, just sort of easy way of doing C. Like C8 should look like a stop sign, right? So C5 looks like a house. So there's my C5 with a methyl on the side. So how many carbons have I got? 6 in total. 1, 2, 3, 4, 5, 6. Count them. How many hydrogens have I got? 12. Oh, same looking form as all the other ones we've been doing.
Doesn't the
So is this one an isomer as well?
isn't the C on the bottom right missing? So, like it's only attached to 3 things.
It's a
CH.
double bond.
Or you can set H.
Oh, no. I'll write it so that's more familiar for what you're used to. C, H, H. Is that what you wanted?
On the bottom right.
Oh, this one? Oh, yeah, this one's missing an H2. Sorry. Yeah. Sorry. Pardon me. Okay, so C6H12, still an isomer, right?
Yeah.
Different structural formula? Same molecular formula, must be an isomer. How do we name it? Okay. A lot of you want to, what are you saying with this? What are you trying to say?
Cyclo.
Cyclo, right, cyclo. Okay, we'll put the methylene up here, like we did before. How many are in a circle? How many are in a cyclo? Pent, 5.
Because the methyl can be anywhere.
Right. And pent what? Pentane, because it's all single bonds. Okay? So pentane, just like it was before, cyclo, because they're in a circle, and methyl, because I've got a methyl hanging off of it, as if it was a branch. And if you want to, you could put 1 methyl cyclohexane if you love your numbers.
So does it matter? Like
No, because I
what
can just
number
take the
you-
wheel and turn it, and the methyl can be anywhere, right? So you don't need the number, but if you want to, you can put the number in.
What if you have
You would
two?
need it if you had 2, because you'd need to tell me whether they were side by side, or if they were one's missing, or yeah.
So would you say like 1, 2?
Yeah, 1, 2, or 1, 3. Yeah, always a 1 though. Okay. So I've really pushed you, because not only have we named alkenes today, we've also named cyclo compounds. So that's a lot of naming that you've just sort of had thrown at you. Oh yeah, that's the end of that. This sheet here, we're just going to skip over it. Okay? And we're going to go into that sheet there. This first bit are all alkanes, just a bit of a warm up. Okay? Oh. Really? Did I give you the wrong sheet? This is just so not happy for me today.
No, this is awesome. We should work on our alkenes.
We should work on our alkanes, but do you know what else we have to work on? Our reactions that we did yesterday. Okay? So, the first thing I'd like you to do is finish your reactions from yesterday.
I don't.
I totally forgot about
And then 2, you can do this chart. And that might bring us to the end of class, or you can start on this booklet. And that'll bring us to the class. I'm going to find some alkene sheets, which should have been in this package. This is just a bit of a disastrous photocopying morning for me. And then that should bring us to the end of our alkene practice.
Yeah, seniors and old person. Can I make this go to the washroom?
Yes, you may.